All right, our goal today is to tackle the zero product law. Now this probably looks familiar because you did solve equations before. We just have all this type of factoring under our belt. So all this law says is that if A times B equals 0, then either A has to be 0 or B has to be 0. And I think you'd agree with that. If something times something is 0, one of these numbers has to be 0. That's all it says. So how do we solve this? Well, we have to make sure that we've got our equation equal to 0, and then we call, you might have heard the phrase, tee it up. We're going to take our factors, we're going to tee it up, we're going to make a t between our two factors after it's set equal to 0, and then you set each one of these equal to 0. So I'm going to set x plus 1 equal to 0 and x minus 2 equal to 0, and then I solve for x. So in this case, I'd subtract 1, so I'd get x equals negative 1. In this case, I'd add 2. I would get x equals 2. And what we call these are our solutions. Okay. In example B, I'm going to kind of do a double T. Every time I see a multiplication, that's where I'm going to stick a T in. So I'm going to T here and here. Okay, so I'm setting each of these three equal to 0. So I'm going to get x equals 0, 2x minus 3 equals 0, and 4x plus 1 equals 0. This one's already solved. It already says x equal. This one I'm going to add the 3 over and then divide by 2. So I'm going to get a 3 halves. Here I'm going to subtract the 1 and divide by 4. So I'm going to get negative 1/4. So I'm going to get 3 answers in this case. Notice I have 3 x's, so I should get 3 answers. So how do we do this? To solve an equation by factoring, you want to write the equation so that everything is on one side and 0 is on the other. None of this works if that doesn't happen first. Then you factor completely with one of our 6 methods. You're going to set each factor equal to 0 using the zero product property. And as a reminder, however many x's there are is how many answers you should have. And then you solve and you can check your answer. So let's see. I'm going to start with some easy ones. We're not going to do all of these, but we'll start with some easy ones here. Let's start with example C. My equation is set equal to 0. So now I can factor. So I have trinomial factoring. That's one of the 6 we talked about. So multiply, add, multiply. Multiplies to x squared. It's just x times x. Multiplies to 4. I can go 1 and 4, 2 and 2. The only pair that can make a 3 would be 1 and 4. To get a negative 3, I would want a negative 4 and a positive 1. Now I can continue to set that equal to 0. There's one multiplication, so I'm going to tee it up between that multiplication and set each of these equal to 0. Then I'm going to solve each side for x. So I'm going to subtract 1 here and get x equals negative 1. I'm going to add the 4 over here and get x equals 4. Okay, how do I know if my answers are right? Well, I can do a quick check. So I'm going to take my negative 1 stored into x, and then I can type in my equation and make sure I get 0 as an answer. I can do the same with 4. Type in my equation and make sure I get 0 as an answer. All right, now I'm going to move through these fairly fast because this is all a review of factoring and teeing it up again you did in Algebra 1. So let's go through D. So pause it and slow it down when you need to. I want to set my equation equal to 0. So I'm going to move these two over to this side. So I'm going to go 2x squared minus x minus 3 equals 0. Again, I see trinomial, so I'm going multiply, add, multiply. So this is that second type of trinomial where I have to guess and check. Fairly nice. 2x and x are the only things that multiply to 2. 3 and 1 are the only things that multiply to 3. So now I'm going to guess if the 1 goes here and the 3 goes here or the other way. So again, we check the arc on the outsides and the insides. Let's see, if I put a 3 here, that would be a 6 and a 1. That can't make 1. So I'm going to guess my 3 goes here and my 2 goes here. 3 and 4, that can give me a 1. I want a negative 1, so I need my bigger number to be negative, my smaller number to be positive. Make sure it still says equal 0. Here's my multiplication, so I'm going to tee it up between my multiplication, my factors. So 2x plus 3 equals 0, and x minus 2 equals 0. I'm going to subtract 3 and divide by 2. So I'm going to get a negative 3 halves, add my 2 over, and I'm going to get x equals 2. I want you to circle this 2 up here. This is telling me how many solutions I should have. X squared means I should have 2 solutions. I could do the same thing here. X squared, I should have 2 solutions. All right, letter E. So again, we're running through all of our factoring types. I have to set this equal to 0, so I'm obviously going to subtract my 4x over. Okay, now I have 2 terms, so my trinomials are out. Okay, grouping's out, that's a 4 term. So I either have GCF, difference of perfect squares, or difference of perfect cubes. Hopefully you recognize a GCF right away. I can pull out an x, and I'm left with x minus 4. Here's where the times is, so this is where I'm teeing it up. This 2 is telling me I should have 2 answers. X equals 0 is 1. X minus 4 equals 0, add that over, and I get x equals 4. My 2 solutions are 0 and 4. And again, I could check those on the calculator. Moving on to F. I need this side to equal 0, so I'm going to subtract my 9. Okay, so 2 terms. Trinomials out, factor by groupings out. It's either a GCF, difference of perfect squares, or difference of perfect cubes. Hopefully you're recognizing difference of perfect squares. That's our conjugate multiplication. Y times y gets me y squared. 3 times 3 gets me 9. 1 gets a plus, 1 gets a minus. Here's the factors, the times. Squared is telling me I should have 2. So I have y plus 3 equals 0. Y minus 3 equals 0. Y equals negative 3. And y equals positive 3. All right. Letter G. Problem number 1, I have to equal 0. Problem number 2, this can't be factored. I have to distribute first. So I have y squared plus 4y minus 45 equals 0. Then again, I'm going to see a trinomial, multiply, add, multiply. So y and y. Let's see, 1 and 45, 5 and 9. I think that's my winner. That can get a 4. And again, I'm moving through my factoring. We have done factoring for 6 days now. We're going to move through this quick. I'm going to go plus 9 and minus 5 equals 0. Here's my times, my factors. So y plus 9 equals 0. Y minus 5 equals 0. So I'm going to get y equals negative 9 and y equals 5. And again, I have a y squared, so I should anticipate 2 answers. Letter H. Oh, letter H is a gift. Look how nice this one is. It's equal to 0, and it's already factored. Okay, so I'm going to tee it up between all my times. So that's 4 times this quantity times this quantity. So I'm teeing it between all the times that I say. So this is going to say 4 equals 0. First, is there even an x here? No, there's no x. And 4 equals 0 doesn't make sense. That means nothing. So I'm going to set 5x minus 6 equal to 0 and 3x minus 8 equal to 0. 5x equals 6, so x equals 6/5. 3x equals 8, so x equals 8/3. So 2 answers, and that should make sense. If I FOIL this out, I'm going to get a 15x squared. Squared is going to be my highest x, so again, I'm anticipating 2 answers. All right, letter I. Let me just talk out. Okay, I can't leave these factored. I'm going to have to FOIL this out. So I'm going to FOIL fast here. X squared plus 4x minus 5x would be minus x minus 20 minus 52 equals 0. Then I'll put my like terms together. Then I'll factor and solve. Okay. Again, our factoring should be pretty legit by now. Let's see, x and x, 9 times 8, that can make a negative 1 if my 9 is negative and my 8 is positive. Here's my times. I'm going to tee it up between those two. X minus 9 equals 0. So x equals 9. X plus 8 equals 0. So x equals negative 8. All right, I want to keep cruising on until we get to some good ones here. Let's try J. Trinomial. Okay, but I've got to notice something first. A, it's equal to 0, like that. B, I've got to recognize that it has a GCF. Now also, look at this. This 3 is telling me I'm anticipating 3 answers. So I'm going to pull out an A. So I'll have 6a squared plus 5a plus 1 equals 0. And I've got to factor this bear. Okay, it's a trinomial. So it's multiply, add, multiply. It's just the annoying guess and check because this number is bigger than 1. Shoot, and I don't have a pencil. So I'm going to write really light and hope I can get this to work. So I can either use 6 and 1 or 3 and 2. This last term has to be a 1, so that's nice. This tells me the signs have to be the same and they both have to be positive. So let's go. If I went 6 and 1 and they both had to be positive, that's not going to work. I think I got to go 3 and 2. Let's check. The inside would be 2. The outside would be, oops, that should be an A, sorry. The outside would be 3. 3 plus 2 is 5. That works. Okay, now remember, I wanted 3 solutions. Every time I see a times, I'm going to put a T. A times 3a plus 1 times 2a plus 1. So I have a double T here. Here I'm going to get a equals 0, 3a plus 1 equals 0, and 2a plus 1 equals 0. A equals 0 is an answer. That makes sense. Here I'm going to get 3a equals negative 1, a equals negative 1/3, 2a equals negative 1, a equals negative 1/2. So 3 solutions because I have an x cubed power. All right, let's get into some of our other factoring. Letter K. 1, 2, 3, 4. 4-term polynomial tells me I now have to do factor by grouping. So I'm grouping the first 2 and the last 2. And remember, this is all about GCFs. I'm going to pull out a GCF here. These two share an x squared. And I'm left with 3x plus 2. Now I know I want 3x plus 2, so that helps me determine what this is going to be. I need this to become a 3 and this to become a 2. 9 is jumping out at me. 9 times 2 is 18, 9 times 3 is 27. I need this to be a positive 3 and a positive 2, which tells me I have to divide by a negative 9. Will get me 3x plus 2. Okay, so now I factor out the binomial GCF. They both have a 3x plus 2 in common, and I'm left with x squared minus 9. Now I'm not factored completely, and again, this is telling me I need to get 3 solutions. So if I look at this bear, I see, oh, difference of perfect squares. So I have 3x plus 2, x plus 3, and x minus 3 equals 0. Okay, so that's factored completely now. And now I can tee that up. That's a times, that's a times. And I'm going to tee each of these up. So I'm going to get 3x plus 2 equals 0, x plus 3 equals 0, and x minus 3 equals 0. Let's see, this one's going to get me x equals 3. This one's going to get me x equals negative 3. This one I'm going to subtract 2 and divide by 3. I'm going to get x equals negative 2/3. So there are my 3 solutions. It was x cubed. I'm anticipating 3 solutions. All right, let's try L here. 4-term polynomial. So there's that grouping again. Okay, it's equal to 0. Life is good. Pull out the GCF first here. I'm going to get 9x squared, and I'm left with, that becomes a 2x, there's a plus sign, and that becomes a 1. Okay, now I need 2x plus 1. Here I have negative 2x minus 1. I need the signs to change, so again, I'm pulling out a negative 1. We'll change those signs. So 2x plus 1 equals 0. Now I'm going to pull out that binomial GCF. So I'm going to pull out the 2x plus 1. And I'm left with 9x squared minus 1. Okay, so if I tee it up here, I don't have enough solutions. Remember, I'm getting 3. I've got to recognize I got to factor that there again, right there. That's a difference in perfect squares. So I have 2x plus 1, I have 3x plus 1, and 3x minus 1 equals 0. Again, I'm going to multiply between those factors, and that's where my t's are going to go. Okay, I'm setting each piece equal to 0. So again, if I'm talking too fast at home, you pause it when you need to. Okay, a lot of this is review. That's why I'm moving a little quicker now. I'm just going to state my answers out here. I'm going to get an x equals negative 1/2. Yes, I'm doing some mental math. X equals negative 1/3, and x equals positive 1/3. All right, so how do they make them a little uglier? Well, if you look at M, here's a quick way to make it uglier. All right, they make you do a lot more work. So first of all, this says squared. If I square something, that means I've got to write it out twice. And if there's a plus and minus, I've got to FOIL that sucker out. So on this side, I'm getting x squared minus 2x is minus 4x plus 4. This side, I've got to distribute. Equals negative 4x minus 8. Now remember, I can't factor until this side says equals 0. So I'm going to add the 4x and add the 8 over. So I'm going to get x squared. Those are going to cancel. Plus 12 equals 0. Okay, now this one's a little different. I don't have a GCF. I don't have a difference of perfect squares, and I don't have a sum of perfect cubes. How the heck are we going to solve this one? Well, watch this. We're actually going to get that 12 back over here by subtracting 12, and then we're going to take the square root of that answer. Now when we take, oh, Jiminy Crickets, I'm getting a negative. So unfortunately, I must have a typo in here because I didn't want to get an imaginary number yet. We're going to call this plus or minus the square root of negative 12 for today. When you take a square root back from your Algebra 1 days, you get plus or minus, and we're just going to leave it like that today. Okay. All right, I'm going to jump down to the one I made up. So that's not in your book, but that we need to review this. So the one I made up is going to be letter O, x cubed plus 8. Okay, so there's only two terms. So either it's GCF, difference of perfect squares, or sum and difference of perfect cubes. So when I look at this, I always start with GCF, no GCF. It's clearly not a difference, so it's not a difference of perfect squares. So it's got to come back to our perfect cube rule. So again, just recognizing that is super important. The good thing is the cube factorization is given, the silly rule here. Okay, so all you have to do is identify the A and the B, who is being cubed. So I need to say who is being cubed to get x cubed and who is being cubed to get 8. Okay, now remember, you can take a cube root on your calculator, but I'm hoping you know 8 by now. But if you don't, you can take that cube root of 8 and it spits out a 2. So I know my B is 2 and x is being cubed to get x cubed, obviously. Okay, so again, you don't need to memorize this formula, but you need to recognize when to use it. So I'm going to go to the addition version. So it's a plus b. So in this case, it's going to be x plus 2. It's x squared minus a squared, which is my x. I'm just going to put that under there so you can see it at the same time, hopefully. Okay, so that's my x plus 2. So I'm going to plug in my a, which is my x squared, minus x times 2 plus 2 squared. And then I'm going to clean that up. Figure that out. So I have x plus 2 times x squared minus 2x plus 4. Okay, so I'm anticipating 3 solutions. I'm going to tee it up here. That's where my times is. So I'm going to get x plus 2 equals 0. So I get x equals negative 2. I see a trinomial, so I'm thinking multiply, add, multiply. So I can go 4 and 1 or 2 and 2. None of those combos are going to make a negative 2, so this side is prime. So my only real solution is negative 2, which means, again, these have imaginary solutions, which we're going to get to in the next week. But if I see a perfect cube, I want to make sure I can factor that. All right, well, that was a mouthful. Obviously, a big lesson. We want to set these equal to 0 and a great review of factoring.